Yes, ma'am. Namrata Pashupati, ma'am. What happened? Why you have raised your hand?
Huh?
Ma'am, why
Hello?
you have raised your hand?
No, no, I just wanted to say that I was not able to hear.
Actually, we have not started yet. It's
Yeah,
nine.
yeah.
Session is supposed to start at
Sorry.
9:30. We are waiting some more participant to join, but it's 40 participants are there. So, sir, can we start the session? Ranjit, sir.
Yes, yes, ma'am. Now
Uh,
time is 9:35.
it's already 9:35 and 40 people are there, so we can start. Meanwhile, they will be joining.
Sure, sure, ma'am. Sure.
Deepak sir is there?
Yes, yes, I
Deepak.
am connected.
Okay, sir. So, dear participants, I welcome you all in the second day of this ATAL FDP on design thinking. And I welcome expert of the talk, Dr. Deepak Jhawar from Engineering College Ajmer. Sir is working as assistant professor there. Dr. Jhawar did his BE in honors from MBM Jodhpur and PhD from MNIT Jaipur. Sir is having more than 2 years experience as a scientific officer at BARC, Mumbai, and 4 years experience in industry and about 20 years of experience in teaching till date. Dr. Jhawar published 28 research papers in various international and national journals, and he organized various FDPs and seminars. Sir is lifetime member of IETE. Sir, thank you. Thank you for accepting our invitation for being expert in this FDP. I welcome you and I request you to start the session, please.
Thank you, ma'am. We should wait of Dr. Bora, sir. Should we wait?
He will be joined at any time, sir. The time is
Okay,
not
okay.
fixed now.
Sir, his
Okay,
work
we
is to
can
review
start.
his work is to review the FDP, so he can join anytime and whenever he joins, we'll
Okay,
definitely.
so I should share this, my
Yeah,
presentation?
sure, sir, sure. Sir.
Okay, thank you, ma'am. Is it visible?
Yes, sir, it's visible.
Because after the sharing, I am not able to see the faces of candidates and others, participants.
Your screen
So
is
any
visible.
problem is there? Please
I
tell
will,
me.
I will inform you, sir. If you.
Okay, okay. Thank you. So I will start. Good morning to all of you. And before I proceed, I will like to extend my thanks to respected Bhamu sir, Principal of the Engineering College Bikaner, Chairperson of this 1 week faculty development program, Shri Rajendra Singh ji, and Dr. Rajoria ji, Organizing Secretary, Dr. Indu Guria ma'am, Coordinator of this program, Dr. Ranjit Singh ji, Rathod ji, and Dr. Prajapat sir, for giving me an valuable opportunity to present my views and sharing my knowledge on this important topic, design thinking, through this unique and important platform of AICT Training and Learning Academy ATAL. Many experts have already shared the valuable insights on this topic, and others would continue to deliberate on this issue. So, treading on the same path, I have chosen this topic, an overview of design aspects in current scenario. Means I will be focusing on the methodologies of engineering design. So, as you know, this presentation is designed as an introduction to how engineering products are designed. This engineering is the creative process of turning any abstract ideas into a physical representation. Means physical representation means products or systems. So what distinguishes engineers from other category like painters, poets, sculptors is that engineers apply their creative energies to producing products or any system that meet with the human needs. His creative act is called design. So we described engineers primarily as problem solvers. So what distinguishes design from other type of problem solving? There may be other types of problem solving is also, which is in nature means both the problem and the solution. So design problems are open-ended in nature, which means they have more than one correct solution. The result or solution to a design problem is a system that possesses specified properties. So if you take a moment to observe your surroundings, you will see examples of technological creativity. The physical objects you see, whether they are light bulbs, telephones, automobiles, bicycles, and electrical appliances, all came into being through the creative application of technology. And these everyday inventions did not miraculously appear, but originated in the mind of human beings and took time to develop. Most engineering designs can be classified as invention devices or systems that are created by human effort and did not exist before or are improvements over existing devices or systems. Inventions or designs do not suddenly appear from nowhere. They are the result of bringing together technologies of different disciplines to meet human needs or to solve problems. So next slide. So design problems are usually more vaguely defined than analysis problems. Suppose, I am taking an example, that you are asked to determine the maximum height of a snowball. Given an, am I audible?
Excuse me, sir, Deepak sir.
Yes.
Dr. Manu Vora has joined.
Okay, okay. So I will stop here.
Indu ma'am. Indu ma'am, am I audible?
Yes, sir, you're audible.
Dr. Manu Vora has joined. Please introduce.
Wait.
Good morning, Baba sir.
Good morning.
Good morning.
Hello.
Hello. Should I
Ma'am, your
continue or Bora
mic
sir will say something?
mic is muted. Indu ma'am, your mic is muted.
Ganpata Ganesha.
Hello. Am I audible now, sir? Actually,
Yes.
I'm at home and working from home. There was my kid just have came. We are fortunate enough that Dr. Manu K. Vora joined us. He's from reviewer from AICT. And this is a matter of pleasure for me to introduce him with the participants. He is chairman and president of Business Excellence in USA since 2000, and he's having 47 years of leadership experience in guiding Fortune to 500 companies. He's 29-year adjunct faculty globally in operation and management. He's contributed 680 educational institutes worldwide. He have delivered 1,200 presentations and published 75 scholarly articles. He wrote 50 blogs, posts on the quality management, and gave 2 TDx talks in 2013 in India and USA. He designed and delivered soft skill programs over 1 million people. He appointed as Fulbright specialist, U.S. Department of State. He's president of Blind Foundation of India. And he did his BTech from IIT, BHU Varanasi, and PhD from Chemical Engineering, IIT Chicago. And he did his MBA in marketing from Chicago. He got 6 medals for quality and 4 medals for philanthropy. It's quite difficult to go through the word. And he have been awarded 56 awards for outstanding professional contribution and 35 awards for lifelong selfless community service. So it's given that it's a brief introduction, but to go through it, I have to struggle for the various points. So we can imagine that how big personality sir is. Sir, I welcome you in this FDP, and we are very blessed to have as a part of this FDP as from AICT. I welcome you, sir, and we are seeking for your guidance in this
Okay.
FDP.
Thank you, Dr. Induji. Glad to be part of this wonderful FDP. So thank you.
I am lucky, sir, that you are joining my session.
Sir,
Just seeking your blessings.
Yeah,
Sir,
pleasure
please.
is mine.
Guidance.
Yeah, pleasure is mine. You can continue, please. Thank you.
Okay. Thank you, sir.
Thank you.
I request Deepak sir to continue the session.
Okay. Thank you, ma'am. So I was asking that design problems are usually more vaguely defined than analysis problems. Means there is a difference between analysis problems and design problems. Suppose that you are asked to determine the maximum height of a snowball. As we are discussing in engineering aspects, so suppose that you are asked to determine the maximum height of a snowball, given an initial velocity as well as release height. So this is an analysis problem because it has only one answer. If you change the problem statement to read, design a device to launch a 1-pound snowball to a height of at least around 160 feet. This analysis problem becomes a design problem. The solution to this design problem is a system having specified properties. Whereas the solution to the analysis problem consisted of the properties of given system. The solution to a design problem is therefore open-ended, since there are many possible devices that can launch a snowball to a given height. So the original problem had a single solution. So the maximum height of the snowball determined from the specified initial conditions. So solving design problem is often an iterative process. As the solution to a design problem evolves, you find yourself continually refining the design. While implementing the solution to a design problem, we may discover that the solution you have developed is unsafe, or it may be too expensive, or will not work. You then go back to the drawing board, chalk and board, and paper pencil and modify the solution until it meets your requirement. We take an example, simple example. The historical example it is, the Wright brothers airplane did not fly perfectly the first time. Means they began a program for building an airplane by first conducting tests with kites and then gliders. And before attempting powered flight, they solved the essential problem of controlling a plane's motion in rising, descending, and turning point. So they didn't construct a powered plane until after making more than around 700 successful glider flights. So design activity is therefore cyclic or iterative in nature, whereas the analysis problem solving is primarily, it is sequential in nature. So the basic 5 steps process usually used in a problem solving works for design problem as well. Since design problems are usually defined more vaguely and have multitude of correct answers, the process may require backtracking and iteration. Solving a design problem is a contingent process, and the solution is subject to unforeseen complications and changes as it develops. So until the Wright brothers actually built and tested their early gliders, they didn't know the problems and difficulties they would face controlling a powered plane. So the 5 steps used for solving design problems are as follows. They define the problem, gather pertinent information, then generate multiple solutions, analyze and select a solution, one particular solution, and then test and implement the solution. So the first step in design process is problem definition. Means this definition usually contains a listing of product or customer requirements and especially information about product functions and features among other things. In the next step, relevant information for the design of the product and its functional specification is obtained. A survey regarding the availability of similar products in the market should be performed at this stage. Once the details of the designs are clearly identified, the design team with inputs from test, manufacturing, marketing teams, they will generate multiple alternatives to achieve the goals and the requirement of the design. So considering cost, safety aspects, other criteria for the selection, the more promising alternatives are selected for further analysis. Detailed design and analysis step enables a complete study of the solution and result in identification of the final design. Means that best fit the product requirement. So following these above steps, a prototype of the design is constructed and functional tests are performed to verify and possibly modify the design. The next step, next slide. So when solving a design problem, you may find at any point in the process that you need to go back to a previous step. Means it is an iterative process. So the solution you choose may prove unworkable for any number of reasons and may require redefining the problem, collecting more information, or generating different solutions. This continuous iterative process is represented in this figure. So you can see here, means you are defining the problem, gathering information, generate multiple solutions, and we can start from anywhere after if we want to modify the design. So the first step in this methodology is define the problem. So you need to begin this solution to a design problem with a clear, unambiguous definition of the problem. Unlike an analysis problem, a design problem often begins as a vague, abstract idea in the mind of the designer. So creating a clear definition of the design problem is more difficult than defining an analysis problem. So the definition of a design problem may evolve through a series of steps, processes, as you develop a more complete understanding of the problem. So in this defining the problem, there are 2 to 3 steps. So first step is identify and establish the need. So before defining the problem, what is the primary requirement is the identify and establish the need. So the engineering design activity always occurs in response to a human need. This is important thing. So before you can develop a problem definition statement for a design problem, you need to recognize the need for a new product system or machine. For example, Thomas Newcomen saw the need for a machine to pump the water from the bottom of coal mines in England. So recognizing this human need provided him the stimulus for designing the first steam engine, which was developed in 1712. So before engineers can clearly define a design problem, they must see and understand this need. Although engineers are generally evolved in defining this problem, they may not be ones who initially recognize the need. It is not necessary that who is designing will recognize the need first. So in private industry, market forces generally establish the need for a new design. So before you delve into the details of producing solution, you need to make sure that you have enough information to generate a clear, unambiguous problem definition that addresses the real need. One more example is there. The following example illustrates this importance of understanding the need before attempting a solution. Example is automobile airbag inflation. How not to solve a problem. So a company that manufactures automobile airbags has a problem with an unacceptably high rate of failure in the inflation of the bag. So during testing, 10% of the bags do not fully inflate. An engineer is assigned the job of solving the problem. At first, the engineer defines the problem as a failure in the materials as well as construction of the inflation device. The engineer begins to solve this problem by producing a more robust inflation device. After considerable effort, the engineer discovers that improving the inflation device does not change the failure rate in the bags. Then eventually, this engineer re-examines the initial definition of the problem. The company investigates the airbag inflation problem. Further, and discovers that a high degree of variability is in the tightness of folds is responsible for the failure of some bags to inflate. That was the main problem. So at the time, the bags were folded and packed by people on an assembly line. So with a more complete understanding of the need, the engineer redefined the problem as one of the increasing the consistency in tightness of the folds in the bags. Then the second step is develop a problem statement. The first step in the problem solving process, therefore, is to formulate the problem in clear and unambiguous terms. There should not be any ambiguity in this when we're defining the problem. So defining the problem is not the same as recognizing a need. The problem definition statement results from first identifying a need. The engineer at the airbag company responded to a need to reduce the number of airbag inflation failures. He made a mistake, however, is not formulating a clear definition of the problem before generating a solution. Once a need has been established, engineers define that need in terms of an engineering design problem statement. So to reach a clear definition, they collect data, run experiments, and perform computations that allow the need to be expressed as part of an engineering problem solving process. So consider another example for defining the statement is, suppose design a better mouse strap. This is our statement. It is a vague statement, but design a better mouse strap. So this statement is not an adequate problem definition for an engineering design problem. It expresses a vague dissatisfaction with existing mouse straps and therefore establishes a need. An engineer would take this statement of need and conduct further research to identify what was lacking in the existing mouse strap designs. So after further investigation, the engineer may discover that existing mouse straps are inadequate because they don't provide protection from the deadly hantavirus carried by mice. Therefore, a better mouse strap may be one that is sanitary and does not expose human beings to the hantavirus. So from this need, the problem definition is modified to read, design a mouse strap that allows for a sanitary disposal of the trapped mouse, minimizing human exposure to the hantavirus. This is the modified statement. So the problem statement should specifically address the real need, yet be broad enough not to preclude certain solutions. So a broad definition of the problem allows you to look at a wide range of alternative solutions before you focus on a specific solution. So here is one possible definition statement for our better mousetrap problem, what it may be. A better mousetrap, certain rodents such as common mouse are carriers and transmitters of an often fatal virus, the hantavirus. Conventional mouse traps expose people to this virus as they handle the trap and dispose of the mouse. So design a mouse trap that allows a person to trap and dispose of a mouse without being exposed to any bacterial or viral agents being carried on the mouse. So another step, when we have already clearly defined our problem statement, we have already established the need, we defined the statement. Then the third point is establish criteria for success. So the criteria for success are the specifications a design solution must meet or attributes it must possess to be considered successful. You should include criteria in the problem statement. Successful criteria for the success, that should be the part of the problem statement to provide direction toward the solution. At this point in the design process, the criteria are preliminary. As the design solution develops, you will most likely find that the initial criteria need to be redefined or modified. The list of criteria is developed by the design team. The design team is made up of people from various engineering backgrounds that have expertise pertinent to the problem. This team may also include people from backgrounds other than engineering, such as managers, scientists, technicians. So the design team must evaluate each criteria and decide if it is applicable to the design effort. For example, if you are designing a critical life support system, you would not include the criteria of must be minimum cost, because cost is not an important factor in evaluating the design. So the following is a list of preliminary criteria for a better mousetrap design. So this list would be included in the problem definition statement. What is that? The design must be low cost. Second, the design should be safe, particularly with small children. The design should not be detrimental to the environment. The design should be aesthetically pleasing. The design should be simple to operate with minimum human effort. The design must be disposable, means you don't reuse the trap. So the design should not cause undue pain and suffering for the mouse. So these points should be included if we are finally designing the mouse trap in better way. Now the second major step in the methodology of design process is gathering pertinent information. Means to gather pertinent information, whatever information related to our information. Before you can go further in the design process, you need to collect all the information available that relates to the problem. So novice designers will quickly skip over this step and they will proceed to generation of alternative solutions. So you will find, however, that effort spent searching for information about your problem will pay big dividends later in the design process. Means gathering pertinent information can reveal facts about the problem that result in a redefinition of the problem. So you may discover mistakes and false starts made by other designers. So what other designers committed mistake in this? So we should rectify it when we are designing it. Information gathering for most design problems begins with asking the following questions. If the problem addresses a need, means that is new, then there is no existing solutions to the problems. So obviously, some of the questions would not be asked. So what are those questions? Is the problem real and its statement accurate? Is there really a need for a new solution, or has the problem already been solved? Then what are the existing solutions to the problem? What is wrong with the way the problem is currently being solved? What is right about the way the problem is currently being solved, what companies manufacture the existing solution to the problem, what are the economic factors governing the solution, and how much will people pay for a solution to the problem, and what other factors are important to the problem solution, like safety, aesthetics, environmental issues that may be included the solution of these. We should search these solutions. Then the next step in this is search for information resources. So as an engineering student, you have many more sources of information available to you than engineers did only in 20 years ago. Means this section discusses some of the most current resources available. But because our world is witnessing an information explosion, by the time you read this, many more resources will be available that are not mentioned here. So traditional publications are still an essential source of information to engineers and scientists. However, electronic information transfer, retrieval quickly becoming a standard source for engineers and scientists. Means when you begin a search for information relating to a design problem, you must be prepared to go to many different sources. The library is still the primary source of the information for an engineering student. So your success as an engineer and student will be enhanced if you are able to use the library effectively. So scientific encyclopedia, technical handbooks, these sources are a good place to start when you are investing and investigating an area or problem that is new to you. An encyclopedia or handbook, design handbook, provides a brief general overview by an authority in a particular field and includes references for more detailed information. Means the McGraw-Hill Encyclopedia of Science and Technology covers all scientific fields. The technical handbooks, such as the Electrical or Electronics Engineer's Handbook, Mark's Handbook of Mechanical Engineer, cover various fields such as chemical, civil, electrical, mechanical, electronic engineering. And the information contained in this handbook is presented in a very concise form and can be good starting point for an in-depth search. So, is it visible?
Yes, sir.
Okay, thank you. So for specific help on using our library, you should consult the library staff at the college. Every college has good library nowadays. And some of the common resources available at a university library are. So electronic catalogs given a listing of all the sources available at your library. The catalogs allow search for subject matter, author, title. They give a brief summary of the book content, including the title, author, publisher, copyright data, other details. Indexes categorizing current works in the various disciplines. They list the subject, title, and author of recent articles in technical and trade journals under various subject headings. So some indexes include a brief abstract of the articles, of those articles, which are published in detail. So the engineering index is another particular index for engineers. It selects articles from approximately around 3,000 journals and periodic publications and includes an abstract of each article. Then internet, nowadays there is a wealth of information on the internet from a variety of sources, manufacturers, professionals and trade organizations, suppliers of products, and many government agencies have valuable resources on their websites. Search engines such as Google.com offer tools to locate relevant information quickly and efficiently. Then third major step in this methodology is to generate multiple solutions. So the next step in design process begins with creativity in generating new ideas that may solve this problem. This one step, generate this will generate multiple solutions. So creativity is much more than just a systematic application of rules and theory to solve the technical problem. You start with the existing solution to the problem, then tear them apart, find out what's wrong with those solutions, and focus on how to improve their weaknesses. Concisely combine new ideas, tools, methods to produce a totally unique solution to the problem. So this process is called synthesis. Casey Golden, in his age of 30, did this when he invented the BioT. Then Casey noticed that discarded and broken wooden golf tees littered golf courses, damaging the blades and tires of lawn mowers. So what he decided? He decided to design a new biodegradable tee. After experimenting the different mixtures, he devised a recipe made of recycled paper fiber and food byproducts, coated with a water-soluble film. So when this film is broken, the moisture in the ground breaks down the tea within 24 hours. So as a result of his creative efforts, Casey's family started a company to manufacture bioteas, producing several million teas per year. So you can see how the multiple solutions can be generated. Psychological research has found no correlation between intelligence and creativity. Means people are creative because they make a concise efforts to think and act creatively. Everybody has the potential to be creative. Everybody knows, engineers especially. So creativity begins with a decision to take risk. So listed below are a few characteristics of creative people, which is must for a good creative people, constructive people. So these are not rigid rules to be followed to experience creativity. You can improve your creative ability by choosing to develop these characteristics in yourself also. So curiosity and tolerance of the unknown. Creative people have a positive curiosity of the unknown. They are not afraid of what they don't understand. Openness to new experiences. Creative people have a healthy and positive attitude toward new experiences. Willingness to take risk. Ability to observe details and see the whole picture. So creative people notice and observe details relating to the problem, but they also can step back and see the bigger picture. So no fear of problems. Creative people are not afraid to tackle complex problems. They even search for problems to solve. They seek solutions to problem with their own abilities and experiences if possible. Ability to concentrate and focus on the problem until it is solved. So the creative people can set goals and stick to them until they are reached. They focus on a problem and do not give until the problem is solved. They have. So what they have: persistence, tenacity. Solution to engineers' design problems do not magically appear. Ideas are generated when people are free to take risk and make mistakes. Brainstorming at this stage is often a team effort in which people from different disciplines are involved in generating multiple solutions to the problem. Now the fourth major step in this design problem methodology is analyze and select a solution. We have generated multiple solutions. Now we have to analyze and select a solutions. Means once you have conceived alternative solutions to your design problem, you need to analyze those solutions thoroughly and then decide which solution is best suited for implementation. So analysis is the evaluation of proposed design. You apply your technical knowledge to the proposed solutions and use the results to decide which solution to carry out. You will cover the design analysis in more depth when you get into upper level engineering courses, means MTech and others. And at this step in the design process, you must consider the result of your design analysis. This is a highly subjective step, should be made by a group of experienced people. So this section introduces a systematic methodology you can use to evaluate alternative designs and assist in making a decision.
Excuse me, sir. Sorry for
Yes,
interruption.
yes, sir.
Sir,
Please.
kindly show in the full screens. Some participants are not visible. Show your screen properly.
But the slide is, I think it is visible.
Slide is visible, but they want it will should be showing the full screen so that it can be more visible. It is a PDF, sir. Just with the Control L, you can show in the full screen.
Control L. Probably I have make this in, actually it is in the small width. So
Okay.
probably it should be visible to you.
Okay. Okay.
Actually,
Okay. No
presently
issues.
I have not much experience about how to expand this. It may disturb otherwise.
No issue, sir. Continue, sir, please.
Okay, thank you. So analysis of design solution. So analysis of design solutions is before deciding which design solution to implement, you need to analyze each alternative solution against the selection criteria defined in the first step. You should perform several types of analysis on each design. Every design problem is unique and requires different types of analysis. So the following is a broader list of analysis that may need to be considered. Bear in mind that the importance of each varies depending on nature of the problem and the solution. So the functional analysis, this part determines whether the given design solution will function the way it should. A design solution that does not function properly is a failure, even if it meets all rest of the other criteria. So for example, the invention of a ball pen. So this common instrument was first invented and manufactured during Second World War, and the ballpoint pen was supposed to solve the problems of refilling and messiness inherent to the fountain pen with ink pen. So unfortunately, this new design had never been evaluated for functionality. So the early pens depends on gravity for the ink to flow to the roller ball. This means that the pens only worked in a vertical upright position and the ink flow was inconsistent and sometimes it flowed too heavily, leaving smudgy blotches on the paper. So other times the flow was too light and markings were unreadable. So the first ballpoint pen tended to leak around the ball, so ruining people's clothes. So then finally an elastic ink is developed in 1949 and allowed the ink to flow over the ball through the smooth capillary action. So not until the 1950s did the ballpoint pen finally became a practical writing instrument. Then thanks to this proper ink, that is elastic ink and engineering behind it. Then decision process, is it visible, sir? This slide is visible?
Yes, sir, it's
Hello?
visible.
Okay, thank you. And okay, I will go back to this. Some other parts we need to discuss. Then ergonomics is the human factor in the engineering. So it is the study of how people interact with the machine. So people occupy a space in or around the design. They may provide a source of power or control or act as a sensor for the design. For example, people sense if an automobile air conditioning system is maintaining a comfortable temperature inside the car. So these factors form the basis for human factors. Or ergonomics of a design means how to interact with the people, with the machines, people will interact with the machines. So a design solution can be considered successful if the design fits the people using it. Nowadays, AI is coming in replacing this whole thing. So AI is making the user friendly between the instruments and the persons. So this platform developed by is very much different problems, complicated problems is solved because of this AI. So the handle of a power tool must fit the hand of everybody using it. The tool must not be too heavy or cumbersome to be manipulated by all sizes of people using the tool. And the third point is in this is that product safety and liability. The primary consideration for safety in this product design is to assure that use of design does not cause injury to humans. It is also must. Then economics and market analysis is also required. So the net result of purpose of most engineering design is to produce a product that generates a profit for the company when we are producing it. So obviously each alternative design has to be evaluated against the criteria, means all sales, potential market, cost of manufacturing, advertising, and other things. And then mechanical strength analysis. The engineer conducts mechanical analysis to answer questions such as will the device or structure support the maximum load that it will be subjected. Many systems generate heat, so you need to determine if the design can dissipate all of the heat being generated during normal operation. So now come to the next slide, that is decision process. So after analyzing all alternative solutions, you need to be decide and document which design solution is the best. So you will refine and develop the best solution in more detail during the later stages of design process. So one widely used method to formalize the decision-making process is the decision matrix. So the decision matrix is a mathematical tool you can use to derive a number that specifies and justifies the best decision. The first step in creating decision matrix is for the design team to rank in order of importance. So the desirable attributes or criteria for the design solution. These attributes can include factors such as safety, manufacturing consideration, the ease of fabrication and assembly, then portability, then compliance with government regulations, etc. So you then assign to each attribute or criteria a value factor related to the relative importance of that attribute. But we have to arrange these in hierarchy. What is the requirement? Which is the priority wise. So for example, suppose you decide the safety is twice as important to the success of your design as cost. So you would assign a value factor of 20 for safety and value factor of 10 for cost. So you assign value factors on a basis of 0 to 100 scale and representing relative importance to each criteria to the decision. And next, you evaluate each design alternative against the stated criteria. A rating factor is assigned to each solution based on how well that solution satisfies the given criteria. The rating factor is on a scale of 0 to 10, with 10 representing a solution that satisfies the given criteria the best. To make an accurate evaluation, you need as much information as possible, and unfortunately, engineers seldom have enough information to make a perfect evaluation. So the following example illustrates the use of a decision matrix and deciding the best alternative design for a can crusher. So in this next slide that we see this. So in this aluminum can crushers, students are being asked to design a simple device to crush aluminum cans in the project. So a student design team proposes 4 solutions to the problem. They develop 6 criteria that are important to a successful design. The student team agrees that the most important criteria of the design and assigned weights are, that is safety 30%, and we have given it 30 points. Ease of use 20%, 20 points. Portability 20% means 20 points. Durability and strength, that is 10%. Use of standard parts 10%, 10 points. And cost finally, which is the least, so that is 10%, 10 points. Here is some diagrams. So this team also proposes 4 alternative solutions to this problem, which are illustrated in the here in figure. So they are a spring-loaded crusher. You can see this diagram, a foot-operated device, a gravity-powered deadweight crusher, and an arm-powered lever arm crusher. So there are 4 kinds of designs suggested by the students. And here is the decision matrix. So after analyzing each solution against the 6 criteria, the team evaluates each design alternatives. And the result of this decision matrix are illustrated in this table. You can see here, first column is criteria, means safety. Then ease of use, portability, durability, standard parts, cost. This is in first column. So the rest of the columns are weight, design. There are 4 types of design, and what kind of criteria, what kind of score we have given to those. So safety 30, it is the most on top priority. Safety is, so in design 1, here it is 2.2 into 30, that is 60. Then 9 point in this design, second design, so it is 9 into 3, that is 270, so like this. Then ease of use, it is 20. Here it is 8, 9, 6, 9. These points are given in these 4 designs. Then portability, like this, durability, standard parts, cost, and finally, if we make this total, it is coming 530 in design 1, 710, 413, 850. But our top priority is safety. So the rating factor R is assigned according to the following scale. You can see here, excellent means 9 to 10, means which criteria we have considered on which scale. So if it is excellent, means safety is meeting the excellent requirement, whatever required. So it is 9 to 10 points, good 7 to 8 points, fair 5 to 6 points, poor 3 to 4. And then if it is not satisfactory, that criteria is not meeting in that particular design satisfactory, that is unsatisfactory, 0 to 2. So design 4 was chosen the best design, largely due to rating aside. You can see other points also here. So it is meeting all the criteria in proportionate. So it is giving the best design solution for this. Likewise, we can analyze other also, and we can form the decision matrix. And then finally, the test and implement the solution. When we have analyzed something that is we have done, we have selected the particular solution, then test and implement the solution. So the final phase of the design process is implementation. Means you can develop a prototype, which refers to the testing, construction, and manufacturing of the solution to the design problem. So you must consider several methods of implementation, such as prototyping, concurrent engineering, as well as distinct activities that occur during the implementation, such as documentation. We can document the design solution and applying the patents also. If design is completed in all respect, you can go for patent. So what is prototyping? As you know, the first stage of testing and implementation of a new product called prototyping means consisting of building a prototype of the product, the first fully operational production of the complete design solution, whatever we have designed. We have to make it physically in a form of model. So the prototype is not fully tested and may not work or operate as intended. So the purpose of the prototype is to test the design solution under real conditions. For example, a new aircraft design would first be tested as a scale model in a wind tunnel. Wind tunnel test would generate information to be used in constructing a full-size prototype of the sorry. So test pilots then fly this prototype extensively under real conditions. Only after testing under all expected and unusual operating conditions are the prototypes brought into full production. After that, you can produce in large scale. First, the prototype, whatever you are doing, you have a physical model that should be tested in the real environment. Then concurrent engineering. The traditional design practices are primarily serial or sequential. Each step in the process is completed in order or sequence only after the previous steps have been completed. The implementation of the design occurs after a prototype or model is created from engineering drawings. A machinist working from the engineering drawings generated by a drafter. Sorry, excuse me. So any machinist implementation or design occurs after this prototype model is created from engineering drawings. So a machinist working from the engineering drawings generated by a drafter or any engineering tools make this prototype. Only after creating a prototype of the design would the engineer discover that a hole was too small, parts didn't made properly, or a hand grip was misplaced. It may be possible. So the part would have to be redesigned and the process completed until a satisfactory solution was reached. That is the concurrent engineering. So the concurrent engineering is the ability to implement parallel design and analysis in which safety, manufacturability, serviceability, marketability, and compliances issues are considered early on and during the process. Means concurrent engineering is however possible through the application of modern computer-aided design analysis, manufacturing software. A designer starts with an idea of the new product in which the above all factors are considered and uses the CAD software to create a preliminary design. And engineering designing a bicycle frame, for example, would use concurrent engineering to minimize this weight and maximize the supported load in the new frame design. Then documentation. Documentation means one of the most important activities in design is documenting your work, whatever you have done till now, this, including all the steps. Clearly communicating the solution to your design problem so someone else can understand whatever you have created. Usually, this consists of a design or technical report. Communicating the solution to a design problem through language means both written and oral way also. It is a vital part of the implementation phase. So many people you will communicating with do not have technical training and competence. They may be the general public, government officials, they may be business leaders also. So successful engineers must possess more than just technical skills. The ability to communicate and sell a design solution to others is also a critical skill of an engineer. Then finally, if design is successful, it is foolproof, no fault, no error is seen, and the target users are satisfied with your design, then you have to go for, you can apply for patents. Means you will develop an original and novel solution to a design problem. Part of the implementation phase may include applying for a patent on your solution. A patent will not protect you from someone else copying your solution, but it does give you specific rights to make and sell your design for a specified period. A patent is an agreement made between you, the designer or inventor, and the government. So through a patent document, you agree to make public all the details and technology of your invention. Most engineering design problems fall into the patentable categories of utility patents or design patents. So all mechanical, electrical, electronic devices fall into the category of utility patent, which is granted for, may be changed in nowadays. So for 20 years. So at the end of patent period, your protection expires and anyone can copy, manufacture and sell your invention without giving you credit or payment. So the design patent is granted to protect the styling or ornamental features of the design. A design patent is only granted for appearance of an item, not for how it works or it will be made. For example, if you invent a telephone that looks like a shoe, yeah, any other object, then you might apply it for a design patent. The design patent would be granted on the appearance of the phone, not on the electronics behind it or whatever mechanical working of this phone. So the design patents are granted for different periods depending on the patent fee paid or whatever it is. In US, in India, it may be different for this. So finally, the testing and verification. The testing and verifications are important parts of this design process. So at all steps in this process, you may find that your potential solution is flawed and have to back up to a previous step to get a workable solution. So without proper testing at all stages in this process, you may find yourself making costly mistakes. So you can improve the design if some flaw is there. So after studying all test data and evaluating design solutions, you may need to make changes, share results, and continue to see how your team could make this solution better, or iterate your design to make the product the best it can be. Means we can repeat, as you are told, it is iterative in nature, this methodology. So iterate to repeat an already completed task to this incorporate new information. So now is the time to improve your design before production begins. You can improve many times finally. Then during this improved design phase, you may consider new ideas or you may incorporate new ideas those before finally producing in your or manufacturing this in the industry. So if you are ready to give design thinking a go, then there are some tips to get you to be started with this. Appoint design thinking champions, engineers within your organization, if it is industry. Then start small so you can test the process, leverages existing surveys and feedback data from constituents, and consider the who, when, where, and why of new solution. So these questions should be asked by yourself. Means consider the who, when, where, and why. These four questions. And think ahead, innovate, not just for today, but for tomorrow also. So by encouraging a human-centric approach, design thinking helps to not only enrich the development process, but also boost the adoption of new solutions that improve the constituent experience also. Means if teachers are the designers, then an essential part of our profession is the design of curriculum and learning experience to meet specified purposes. In a learning-centered campus, so the student learning is the most significant goal of the university, as we know. So thus, just a minute, please. Sorry, sir. Sorry for interruption. So in this, as we were talking about this teachers and students. So learning-centered campus are there in the universities, and student learning is the most significant goal of the university. So thus, the student should always be kept first in mind when addressing the why and what questions to formulate the problem, as well as the how when deciding on creative strategies. What are the strategies of designing to identify the best solution? So design thinking is considered as an integrative process. Some other examples we can take. In 2016, one example is there. So the Braun and Oral B recruited this expertise of designers Kim Collin and Sam Hest, founders of the London-based design studio, industrial facility was there, to create a smarter electronic toothbrush. So when they initially partnered with Braun and Oral B and Braun was recruited for this. And the manufacturers suggested Collin and Hatch design an electric toothbrush with a variety of sophisticated data tracking features in that, and including a music player, ways to sense how well the users were brushing every single tooth, and even how sensitive their gums were. So that was all sensors were there in the proposed design of electronic toothbrush. And however, Hatch and Colin quickly advised them to think this more about the customer's experience as opposed to their own vision for the product. Means what the need of the customers is there. So they suggested how a simple additions to the brush could solve many of the frictions their users were reporting. So the Hatch and Colin added on the go USB charging, made it easier for users to order replacement brush heads, both problems that Braun and Oral B consumers had already expressed. So it was latest example it was. And you are also familiar with the Netflix. Do you know this Netflix? An innovator, design thinking practitioners. Netflix, do you know, sir? All participants, I am asking from participants.
Yes, sir. I think everyone knows about the Netflix. Sir.
117 million subscribers are there. 117 million subscribers of the Netflix in around 190 countries. But how did it all begin? So this began in 1997 with the vision of founders Reed Hastings to stream movies directly to the homes of people via internet. So back in the days, Netflix started as a service that delivered movies to the doorsteps of customers via customer mail. So however, soon cable companies began offering movies on demand nowadays. So Netflix used the approach of design thinking. All steps, understood the needs and expectations of its customers, because finally that product will reach to the customer, and customer part is important. If he is not purchased, he is not satisfied, then there is no need to design this. And you can modify, as there is always, it is iterative process. You can modify this design as per the exact requirement of the customer, what he is facing problem. So it is transformed its business model accordingly with the expectations of the customers. One more example we can take. So, PillPack, an online pharmacy, and a former startup, IDEO. It was in the startup in IDEO that was acquired by Amazon, has sought to make the experience easier. So the company created a prescription home delivery system that organizes medications into pre-resorted easy to open packets labeled by the date and time and sends them straight to your door. And date and time is there, means which dose you have to take on which date and which time. So instead of having medications in 5 different prescriptions bottles, in addition to vitamins, supplements, or other medicines are there, and having to remember when and how often take them, how many times. So you receive them all in packets with clearly marked time stamps that you tear open at specified times. Tear them, open it, and take it at that particular time, which is mentioned there. So by understanding customers' need and pain, what are the pain points, PillPack was able to design a more seamless and convenient prescription experience. He is taking continuously feedback. They were taking the feedback from the customers, patients, and they modified it continuously. If you know the food delivery app, which is how we eat, Uber Eats connects people to restaurants in cities all over the world. And each place has its own individual food culture and ecosystem. So Uber realized that to create a product and that would address the unique need of each city. So it needed to immerse and learn about this varied experience of the restaurant workers, delivery boys, partners, customers. So, and another example, we can take a Moonrise, which is a digital platform that matches workers looking for extra shifts with potential employers. It allows people to easily sign up for short-term, on-demand work with a partner organization via phone, get paid as soon as they finish. So they can extra money to pay for unexpected bill and other expenses. So additionally, they are labeled as a kind of employees of Moonrise rather than contractors, which means that they don't pay self-employment taxes. So if you need demand immediately, you can contact them via phone. You do their work, get paid. As soon as they finish, you will finish this work, they will pay you immediately. And that money will come into their mobile, whatever wallet, and you can expand accordingly. So these are few examples are there. There are a lot. There may be a lot of examples. Few and some data is there. Innovation index. If you know this innovation index 2011 to 2021. So average value is 34.97 point in India and 31.7 in 2015 it was, 36.6 in 2019, and it is in 2021, this innovation index is 36.4. Whereas world average is, if we are taking the world average of 132 countries, it is 34.3. The researchers and development, there are a lot of indexes are there that may be. So innovation index is like this. And finally, references of my presentations are as follows. I took matter from these references. These are there are a lot of research paper articles are there in management journals also, engineering journals there. And it is all, it is fundamental of engineering design. You can go through this. There are a lot of materials available on this. So I will end this presentation here.
Thank you, sir.
Okay, anyone want to interact?
Any queries from the participant side, please ask. Yes, any queries? Number of participants has raised hand during the session. Please ask now. Okay, no questions.
It
And
is,
number of participant has asked for the
I
PPT.
tried to explain this conceptually. It's not in advanced way. So, and I have already given sufficient examples
I
on
think all the
at each
participants
and every step.
understand all the things.
Yes,
Okay.
I tried my best. But if you have any questions, then we can.
Participants ask for the PPTs. Sir, if you permit, then I will forward these PPT to the participants.
No problem, sir.
Okay. Thank you,
It is
sir.
already with you, so you can
Yes, sir.
forward it.
Sure, sir. Sure. Okay. Now I conclude the session. On the behalf of all the participants, Engineering College Bikaner and ATAL FDP team, thank you, sir, for this wonderful session. I extend a hearty lot of thanks to you, sir, for sparing your time to this innovative talk. Thank you once again, sir, for that enlightening talk of the first session in this extremely cold condition in Rajasthan.
Yes,
Temperature is around at 4 to 5 degrees centigrade.
yes, yes.
Thank you very much, sir. It was a
Yesterday
nice
it was very much cold.
uh, and it was a very nice
That's why I
presentation.
got some throat problems. So sorry for that because of this
No issue,
disturbances.
no issue,
And
sir.
I am also thankful to all these
There are a lot of
coordinators.
comments from in the chat box also. Very nice presentation. Next, I would like to thank all the participants who joined us with such energy from the various part of the nation.
Grateful
Without you,
to Bora
this
sir
session-
who joined
Sure, sir.
the session.
And it is request to all the participants join again after a short break at 11:45 a.m. And then the next talk will be taken by Professor S.P. Harsha from IIT Roorkee on design, creativity, invention, and innovation. Till then, bye everyone. Thank you.
Thank you, Ganesh
Thank
sir.
you, sir. Thank you.
Indu madam. Okay.
Thank you, sir.
So we may leave.
Sure, sir.
Sure.
Thank you, sir. Thank you.